All right, good morning. So this is going to be a quiz review for quiz 3 for PreCalc here. So let me just get right into it and share my screen so we can start talking about doing some problems here, okay? All right. So quiz 3. What am I going to ask you? I'm going to ask you an exponential modeling program or problem. We're going to do some basic trig. So if you were sitting on the fence, you're like, I don't know if I should memorize the trig functions. You should memorize the trig functions. Okay, so basic triangle. Okay, no problem. 3 is we're going to have some reference angle problems. Okay, and I get it. This is something you have to practice. I'll show you how to draw it. But yeah, I sympathize for everybody who's having trouble with this. It took me a while. Okay, and then we have a word problem, a trig word problem. Okay, so let's get started here. So your basic, not basic, but your exponential modeling. Okay, you have to know 3 formulas. You have to know interest. Okay, you have to know population. Okay, and then you have to know, I think your book uses Q. Okay, 1 for interest, 1 for population, and 1 for radioactive decay. Okay, they're really the same formula. Okay, I really don't care how you spell it. Okay, so if you use this one for everything, you're going to be just fine. Okay, because it's what they mean, and you can always engineer that. So this is your current amount, your initial amount, that's the principal, e to a rate times a time. Okay, and as long as the rate and the time agree with each other, that's how that's going to work. So with R, my growth rate is usually expressed as an APR, an annual percentage rate. So T is going to be in years. Okay. For population, if we're talking about, bigger animals, we're talking about population in years, right? I mean, it doesn't make sense to talk about a human population in terms of minutes or weeks, but it would make sense to turn it into years. But if we're talking about mosquitoes, right, like you want to say, like, well, the summer, when do we spray? You're probably talking about weeks. Okay. And then radioactive decay, it kind of depends as well. It's like, well, if you're making something, right, if you're using one of the colliders, and you've got things that, you could measure in seconds on what the half-life is, time being in seconds would be the appropriate thing. Okay, so there's no real hard fast on what these R's have to be or what the K has to be. Let's just match the T with whatever the K is. Okay, so if we're talking about half-lives that are in days, T is going to be in days. We're talking about half-lives that are in years, T is going to be in years. Okay, same thing with populations, right? If you're growing biology in a lab setting, or if you're growing bacteria in a lab setting, your half-lives are probably in hours. Okay, so time is going to be in hours. Okay, so that's what we're talking about there. Let me just do a problem real quick to see what we're doing. Let's see here. Okay, reinvest $3,000 into a CD that has 3% APR. Okay, that's actually, sadly, that's a rather high interest rate these days. Okay, when will the initial investment double? Okay, so we're going to put $3,000 into a CD, 3% APR. When will that initial amount double? Okay, so this is kind of a slightly easier problem because we don't have to figure out the rate. We'll do another problem in a minute where we do. But what we're going to do is we're going to say, well, we have our amount is equal to our principal, our initial amount. Oh, compounded, we'll say compounded continuously. That's not exactly realistic, but it gives you an upper bound for what that's going to be, okay? Usually the formula that we use for if it's compounded monthly or so, we would use A is equal to P1 plus R over N being compounding periods to the NT. So if it's a month, N is 12, okay? The R, you have to remember to turn it into a decimal, and then we're set to go. I would not expect you guys to memorize this formula, although it is the formula that banks use, okay, to do this kind of stuff. So if you're getting unrealistic numbers, you've done something wrong. And I'll tell you what you've done wrong. You didn't convert this to a decimal, okay? So we're going to use A is equal to PE to the RT. Okay, so our current amount, all right, is equal to, what did we start with? We started with 3,000. Okay, E, what's my interest rate? Well, here's where everybody makes their mistake, 0.03. Okay, if you put in 3 here, that's 300% interest rate. Okay, it's not quite on the level of payday loans or the title car loans, but it's close. Okay, maybe 6, and they'll be set. Okay, and then you have a T here, and this T is going to be T in years. The other thing you'd have to change for the loan shark places, the payday loan places is they charge interest every 2 weeks. Okay, so the compounding period for them is every 2 weeks. All right, when is it going to double? So we're going to say 6,000 is equal to 3,000. E to 0.03 T. They're asking us how long is this going to take to happen? So we're going to divide both sides by 3,000. All right, and we get 2 is equal to E to the 0.03 T. We still have to solve for T. It's in the exponent position. How do we get it down? We take a logarithm. So we're going to say log 2. I'm choosing natural log because the base is an E. Okay, is equal to ln E to the 0.03 T. Okay, this business here, this comes down in front. Okay, so we end up with natural log of 2 is equal to 0.03 T times the natural log of E. What this is asking, E raised to what power is equal to E? 1. Okay, so T is equal to ln of 2 over 0.03. Okay. Let's see here. We have the natural log of 2 divided by 0.03. Okay, about 23 years. Okay, and those are the kinds of numbers you should be expecting. Okay, when you're doing something like this. All right. I find a lot of students, they get like like 2 years. Like, really? You can put $3,000 in a bank and expect double your money in 2 years? Like that's not happening. Okay, it's not happening. The investment folks, banker folks, they use the rule 72. So rule 72, that's 72 divided by the interest rate. In this case, we don't convert it to a decimal. 72 over 3, without having to do any calculations, it would say 24 years. Okay. So that's pretty close. Okay, but that would be a question. Something closer to what I would ask you, just as a warm up. Let's see. We have something. I think radon decays or has a half-life. Half-life of 3.6 days. So, leading cause of lung cancer if you don't smoke. So radon gas. Not as problem as in New Mexico because we don't have basements. Okay, but if you go back east, there's a lot of basements, and radon gas seeps in through the walls. So that's why it's a health issue. That's why you hear the commercials. Okay, so we have radon has a half-life of 3.6 days. Okay, so let's see here. If an initial exposure say I need some amount of radon here. So I don't know how much radon seeps into your house. I don't know these values. So I'm making this up. But if we had say 5 micrograms, and I don't know how much radiation that would give. Okay, the initial exposure was 5 micrograms of radon. Okay, they don't even really measure it that way. They measure it in the radiation, which is going to be in becquerels. Okay, they also use curies, but becquerels is the SI unit. Is becquerels. When will there only be 1 microgram of radon? Okay. So again, what's our model? Q equals Q sub 0 E to the KT. Now your book will make this negative. I just let the negative be implicit inside the K rather than outside the K. Right. It's easier because I get the same formula 3 times and I don't have to worry about where the negative signs go. So this is a 2-part problem. Okay, it's always a 2-part. No, not always, but first thing we got to do is we got to figure out our K. And we're going to do that because we know we have a half-life and a time. Okay, so half-life is when half of it is left. Okay, that's what that means. Half of it, half of the original remains. All right. So if the keys into other elements, we do daughter isotopes and all of that. We're not gonna pursue that all the way down. Okay, we're just going to talk about the initial radon. All right, it's already complicated. So what we're going to say is, well, I don't really care what we started with, but after the half-life passes, right, we have half of it left. So half of the original, okay, is equal to Q sub 0 E to the K. How much time went by? Well, it was 3.6 days. Okay, so we're going to go ahead and solve this. We have to solve for the K first. Okay, so we'll cancel the Q's. So we have 1/2 is equal to E to the 3.6K. Right? Hey, we have a variable in the exponent position. How do we get it down? I want to put it back on the baseline. We take a logarithm. So it's going to be ln of 1/2 is equal to ln of E to the 3.6K. All right. Thing about logarithms is they are side-by-side sort of operations. Do it to one side, do it to the other side. Do not do it term by term. Okay, it's got to be this side takes a log, and that side takes a log. Okay, so it's kind of like squaring. We square both sides. We don't square individual terms. Right? If you have a plus b is equal to c, you can't say, well, a squared plus b squared equals c squared. I mean, that's true for Pythagorean, but I can't just say from this, if I have a plus b is equal to c, and then say, well, let me square this, and then get a squared plus b squared. It doesn't work that way. You gotta FOIL this out. Okay, so same idea. You can't just do logs and distribute them through. It doesn't work that way. But here we are. Okay, so we have natural log of 2 to the negative 1 is equal to 3.6K. This is the rule of logarithms where the exponent can come down in front of the log, ln E. What power do we raise E to, right? Because ln is log base E of E. So it's saying, well, E raised to what power is equal to E? And that's going to be 1. We have 3.6K equals. This negative is going to come down in front. Why did you do that? There's a lot of textbooks do it, so I'm just used to making it look like the textbooks do. Okay, so K is equal to negative 1 over 3.6 ln2. Now I'm just going to put a little r here for the radon, k for radon. We could calculate this out, if you are going to calculate this out, for significant figures. Okay, always for significant figures. Why for? They used to have something called CRC books that we look all this stuff up in, and it was always 4 decimals. So that's what we do, 4 decimals. Okay, that was part 1, right? We know what the K is now. Okay, we know the K. So when will we have just 1? Okay, so we'll go back to the original equation. Q equals Q sub 0 e to the K sub r times T. T is going to be in days, right? Because our half-life was in days, right? So T is going to be in days to deal with this R, this K rather. Okay, we have 1, because that's how much we want to know, equals 5, that's how much we started with, e to the K sub r times T. Let's make it a nice clean logarithm first. So we're going to do a 1/5 is equal to e to the K sub r. We know what this is now, times T. So how do we get T onto the baseline? So we take logarithm of both sides. So ln of 1/5 is equal to ln of e to the K sub r times T. And this whole business comes down in front. Okay, so we have natural log of 5 to the negative 1, you'll say, is equal to K sub r times T times ln e. Okay, ln of e is 1. So we have to solve for T, and T is equal to negative natural log 5, so the negative comes down in front, divided by K sub r. What was K sub r? Right? K sub r is going to be negative 1 over 3.6 natural log 2. So this is, right, this is T equals negative ln 5 divided by, and what do we have here? We have 3.6 over ln 2 was negative, wasn't it? All right, so let's go ahead and invert and multiply. So we pretty much have negative natural log 5 over 1 divided by 3.6 over ln 2. That's not right. Yes, it is. Okay, we're good. Are we? It's natural log 2 over, we'll go back and check. Okay, it's ln 2 over that. Okay. I got it upside down, I'm sorry. All right, so this was ln 2 over 3.6 negative. Okay, we got it backwards. I apologize. Let's fix that. 2 over 3.6. You guys remember how you do this, right? It's invert and multiply. So we have T is equal to, right, ln 5 over ln 2. These were both negative, weren't they? So we don't care anymore. Times 1 over 3.6, or no, times 3.6. Right, times 3.6. Invert and multiply. Natural log is downstairs. 3.6 goes in the upstairs. All right, so here we go. It's 3.6, ln 5, ln 2. Don't try to be cute. Okay, this is a formula for logarithms, but it is not the one you're thinking of. Okay, you need log of 5 over 2 would be ln of 5 minus ln of 2. How many logs do I got on this side? 1. How many logs do I got on this side? 2. How many logs do I have here? 2, but they're in a fraction, they're not minus. So there's not really a lot we could do with this. This is a formula. If we have a log base b of some number that's equal to some kind of a common base of a over a common base of b. So this is called a change of base formula. Don't memorize this, okay? Every once in a while there's a problem that involves it, so remembering that exists is useful, but I can't say that I've used it all that often, okay? So there we go. So let's go ahead and plug this in. So this is 3.6 times ln5 over ln2. So 3.6 times ln of 5 divided by ln of 2. You get something about, it would tell you, okay, it would tell you how many decimals you want, but you know, when in doubt, we're going to pick 4. Okay, 8.359, 3589, and then nothing else. So 3589. All right, and that's it. That's all they want. All right. So just remember, it's a two-part. It's usually a two-part problem, not always. Okay, and the first one, which might be there, it was just a one-step problem. In this case, we have a two-step problem. Okay, so that's how you do radioactive decay problems. All right, it was section 3.6, by the way. Okay, if there's anything more complicated than something that uses these formulas, okay, the first formulas we put up all the way up here, these guys. So these guys you have to know. Well, you have to know one of them, okay, and know when to apply it. If you're doing a problem, it's like it's going to be Newton's law of cooling problem, which is like how fast something cools, or anything else that's a little bit more complicated, I'm going to write that formula down for you. So these are the 3 you need to know. Okay, that's it. It's already enough to memorize in this class. All right, next. Okay. Given a triangle, determine trig ratios. All right. So what you're going to see, right, is a triangle and an angle. Okay. And we're just going to pick 2 of the sides. Okay. So what if we pick something like 9? I don't know. We'll leave that as a B, and we'll say this one's 10. Okay. Remember, the biggest side is the hypotenuse. It's always across the number for an angle here. Okay. And I'd say I'd like to know what are the 6 trigonometric ratios of this triangle. All right. And I don't really care so much anymore if you rationalize denominators. 1 over the square root of 2 times square root of 2 over 2 is equal to square root of 2 over 2. This was done to make life with slide rules easier, and I'm guessing you probably have never touched a slide rule, let alone used one. We have calculators that do this in a moment, so you know, you don't need to go through it. This is a 20th century solution to a 20th century, 19th century, 18th century problem. Okay, because doing this 1.414 into 1, right? That's square root of 2. There's a 2 next. But doing this division problem kind of sucked. Okay, whereas doing this division problem wasn't the best thing you could do, but this is a lot easier to start than this one is. So that's why we converted. Okay, but again, this was for slide rules, for doing manual arithmetic. We don't do that anymore. So this is an artifact. Okay, like archaeology math. All right, so what are we going to do? We're going to say, oh, Pythagorean theorem. So we have 9 squared plus b squared is equal to 10 squared. So this is 81 plus b squared is equal to 100. Okay, so b squared is equal to 100 minus 81. B squared is equal to 19. All right, so b must be the square root of 19. All right. Now, this is square root of 19. I'd like to know things. I would like to know, what is the sine of that angle? What is the cosine of that angle? What is the tangent of that angle? What is the cotangent of that angle? What is the secant of that angle? What is the cosecant of that angle? All right. And you have to remember, okay, if you're using Krakatoa, that's great. Okay, if you're using this, Sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, I'm kind of hoping that at this point, okay, when you're prepping for this, like you would know that, okay. But you know, there are worse things not to know. Well, in other words, okay, this was 10, square root of 19, 9. All right. So opposite over hypotenuse. This is the square root of 19 over 10. Okay, adjacent, 9/10. Okay, tangent, opposite over adjacent. Okay, this was going to be their inverse. Okay, this is 9 over root 19. I'm sorry, I can't help myself here. So we have 9 roots of 19 divided by 19. Okay, secant is the opposite, it's the reciprocal of this one, so it's 10/9. Okay, and this is 10 root 19, and again, of course, a habit after so many years here, 10 root 19 over 19, right? That's all I'm asking for that question, okay? So do you know your trig? Do you know the definitions of the trig? And if you have part of a triangle, can you finish the triangle and solve this? Okay, you think, well, that was an easy question. It don't have to be a hard question. You're going to need this a lot. Okay, so it's one of those things where if you think it's an easy question, fantastic. You're going to be that much better off when you go to physics. Okay, so if this is easier for you, then great, hold on to that. If this is not easy for you, practice until you've made it easy. Okay, this is an important skill for you to have for every engineering class you're going to take afterwards. All right, so that's one to know. All right. Let's see here. We have a tree. Okay, a tree casts a shadow that is, we'll say 10 meters long. Okay, we'll say the angle of elevation. The angle of elevation is, we'll say, 10 degrees. All right, let's go. Something that makes it like, why did you do that? We'll say 12 degrees. All right. How tall is the tree? Angle of elevation to the sun. So first thing, you got to draw the picture. Okay, the instructions, well, actually, the instructions for yours doesn't say draw the picture, but okay, we'll make it one of those trees. Okay, we have angle of elevation. Okay, and then here's the shadow. Okay, angle of elevation is 12 degrees. Okay, this is 10 meters. Okay, first time I taught trig, they made this the shadow. Okay, that was their shadow. I don't know what universe they came from because it's not how light works here, but they always did that. And it wasn't like one person. There was like a group of them that decided the shadow was going to, like, you know, be cast out from the tree up to the sun or something. I don't understand. All right. How tall is the tree? We need to know that H. Okay. Can you think of a trig function that relates the opposite and the adjacent sides to an angle? Wait, I think that's cotangent. Like, well, technically it is. Nobody uses cotangent. Use tangent. Okay, so we're going to say the tangent of an angle is equal to the opposite side over the adjacent side. Okay, so the tangent of 12 degrees is equal to opposite. That's my height, right? That's the height over the adjacent side. The adjacent side was what? 10 meters? 10. All right, so we have 10 times the tangent of 12 degrees is equal to the opposite side. Make sure in the right units. Okay, the biggest mistake people made with this, well, not the biggest mistake. It wasn't this class. It wasn't the current class. It was a long time ago. But the biggest mistake that people make this year okay, is that they don't convert the angle, the degrees into, they don't convert to to degrees. They keep their calculator in radians. Okay, so what you're going to do is you're going to go to mode, and you're going to go down a couple. Okay, you see where it's radian versus degree. We want to change to degrees. Okay, that's how you do it. It's mode. Go down a couple. Just move it over there, and then we're going to quit. We can check it. Hey, look, it stayed degree. All right. So that's what we did for that one. All right. So we're going to have 10 times tangent of 12 degrees, right, equals, and we get a opposite side is equal to, what did we say? It said 2.12 meters. All right. So a little bit more than 6 feet. Okay. So just to give you an idea. So it's not a big tree, but it's a start. Okay. So that's those are the kinds of word problems I'm looking for. Okay, it's a basic draw the triangle out, and then angle of elevation, angle of declination, and then go for it. Okay, I think this is 4.3. The last problem, or one of the last problems, talks about an airplane, how much the descent is. I don't know if you guys remember that one, but that would be a good problem. Okay, this is not your problem for the quiz, but I like that one. But that is not exactly the problem I'm asking you. All right, the last thing to do is reference angles. These gave me a lot of trouble when I was taking trig. Okay, so if you're having trouble with this, okay, you're in the same boat that I was in until I learned how to tell time. Okay, so look, pick any value you'd like. Okay, so why don't we pick 13 pi over 4? Okay, where the heck, I want to know, like, what is the secant of 13 pi over 4 kind of a thing? We got to count. This is 1 pi over 4. This is 2 pi over 4. So isn't that pi over 2? Like, yeah, but we're counting 4s right now. 3 pi over 4, and then 4 pi over 4. The horizontal is always n over n. So regardless of what number I pick here, the one on the horizontal is always that one number over that number, because it's just pi. So if it's pi over 6, we want 6 pi over 6. 4 pi over 4. 3 pi over 3. Okay, something like that. Okay, so that's 4. Here's 5 pi over 4. And we're just going to count it around. I know all the ones around is 8 pi over 4. Okay. And then this is going to be also 12 pi over 4. And then we get to 13 pi over 4. Okay, and we're just, you're not trying to make this is just a mnemonic device to help you count. So wherever you draw these angles, is, you know, as long as they're approximate, because you don't want to put 2 of them in here, you're going to be fine. All right. So as long as you have an idea of like where that angle is, like it doesn't have to be drawn perfectly. This is for you. Okay. We have 13 pi over 4 here. What do we want to know? 13 pi over 4. So the secant of 13 pi over 4, what's my reference angle? It's always back to the horizontal, always back to the horizontal. So the reference angle here is pi over 4. Okay. What is the secant of pi over 4? Well, that's square root of 2. All right. Secant of 13 pi over 4 is pi over 2. You have to use the exact values on the question. Okay, it specifies use the exact values. You give me 1.41423. I'm marking you wrong. Okay, because I want the exact value. And then what quadrant are we in? Okay, remember our signs, SIGNs. Okay, this is all students take calculus. The only function, the only trig ratio that is positive in the third quadrant is the tangent. So this is a negative number. All right. So that's what we're doing for that. So secant of 13 pi over 4, negative square root of 2. All right. Oh, sorry. All right, let's do another one. How about we do a negative 2 pi over 3? Okay. And why don't we do, what's the sine of negative 2 pi over 3? Well, where the heck is 2 pi over 3? Well, the positive angles go this way. Negative angles go clockwise, right? So we're going to do 1 pi over 3, 2 pi over 3. Okay. How much more do I need to get to the horizontal? This is a pi over 3. Okay. So negative 2 pi over 3 is this angle, right? It would also be that angle, all right? And with the reference angle being pi over 3. It's in the third quadrant. It's the one thing you have to remember about this. Okay, so what is the sine of pi over 3? Right? Because that's the one we're dealing with. Okay, sine of pi over 3 is square root of 3 over 2. All right, but it's in the third quadrant again. So the sine of negative 2 pi over 3 is equal to negative square root of 3 over 2. And that's the answer that you're going to put down here is negative square root of 3 over 2. It is not negative 0.866. Okay, that would be wrong because that's not an exact value. This is the exact value. All right. So study some reference angles. Okay, we can draw the pictures. Okay, count them. Okay, if you're stuck on them, count them. It's like a clock. Okay, so don't let this intimidate you. The secret is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Okay, all going on to the negative. You just keep counting them around until you get there. Okay, go the other way. Right? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, so just count it and you're going to be fine. Just remember that the horizontal is like 3 pi over 3, positive or negative, doesn't matter. Okay. But if you have like a couple of little places where you're like, oh, I know where I'm supposed to be, then it'll be okay. For sixes, right, pi over sixes, this is a little bit different because pi over 6, there's 2 of them in each one. So this would be 1 pi over 6, 2 pi over 6. Like, wait, isn't that pi over 3? I'm like, yes, but we're counting in sixes. 3 pi over 3, or 3 pi over 6 rather. That reduces to pi over 2. So we're in the right spot. 4 pi over 6. Yet again, it reduces, but we're just making sure we're in the right spot. 5 pi over 6. 6 pi over 6. Okay? And you just count through that and make sure that you've got the right little picture going on. And then always to the horizontal, okay, to the reference angle. And it's like, how much more do I have to go? Okay, or how much have I gone too far with? But always go back to the horizontal, get your reference angle, and then once you have your reference angle, you're going to know, right, what sine, cosine, and tangent are, but you also know what the opposites are because they're just reciprocal functions, okay? And that's what you're going to write down for it. All right, I'm going to stop. I think we've been good for a review here, but that's what you have to review for this thing, okay? So this was a 4.3 problem. Okay, I think this was a 4.2 problem. And I'm not sure if this was a 4.2, 4.3. I don't think it was a 4.1. But I think it was a 4.2 or 4.3. Okay. Oh, wait. Sorry. This second one here, this may have been a 4.4 here. This one down here. This may have been a 4.4. Okay. But the first half of chapter 4 and the last section of chapter 3, that's what you're being tested on. Okay. So go back and look at those. All right. Practice. If it helps, draw the picture. Okay. Draw the little wheel. All right. It does help. It really does. So I encourage you to do that and work a couple of these problems. And again, Here's your study tip. Okay, it's best if you have a group, but what you're going to do is you're going to pick 3 problems from 4.6. You're going to, or I'm sorry, 3.6. You're going to pick 3 problems where you have to do a triangle and get the trigonometric ratios. You're going to pick 3 problems where you have to do reference angles, and you're going to pick 3 word problems. Okay, and you're going to work those. And if you have to go back and look for a hint, then you get to pile on plus 3 problems. Okay, so you have to do them without asking for a hint or show me how to do this or looking up in a book or looking up at YouTube. Like if you can do it without any help, then you have it. Okay, so you do 3 without looking at any resources, you're okay. If you have to look and like, I don't know this well enough yet, let me go back and try and do it until I can. Think about a test or a quiz as a performance, not as something. Just don't reread your notes. It's a terrible way of studying. Okay, don't reread your notes. I mean, you can, but you're not studying yet. I should say you're not rehearsing yet. Okay, use the wrong verb. 3 problems. Do each of those 3. Do them all. Okay, you can even pick you can pick 3 problems and then do like 1 hour, 2 hours, and then the next hour or something, or before work, after work, and then like maybe after work the next day. You say, okay, I got them all. I'm ready to take it. All right. Do not just reread your notes. Okay, or do a problem where like, oh, I gotta use a hint. There is no hint button on the quiz. All right, you're stuck. So do them until you can't. All right. Yeah. Honestly, I mean, you guys don't play instruments, but if you do, like if you're a marching band, you have to go out and perform in front of, maybe dozens of people, more than that. Okay, but you have to go out and perform, and you can't, if you screw up, everybody's going to know. Everybody is going to know if you screwed up. So you practice, you drill until you have it, so you're not, the mistakes you make are minor. Okay, if you miss one of these, right, the sign error, it's wrong, but it's not the end of the world. Maybe nobody saw. Okay, if you play like one little bit of a wrong note in a very fast passage, they're not going to know. Okay, so practice until you eliminate the big mistakes. Practice a little bit more so you start eliminating the small mistakes, and then you're going to be fine. Okay, so test yourself, quiz yourself, and then say I'm ready. But don't just like, I reread the notes about 6 times. It's a waste of time. Don't do that. You reread them once, it's fine. You reread them a whole bunch of times, it's not helping. It goes the same for all of your classes. So your history class, you want to write down, you want to take notes, you want to write some questions out from the margin. And then cover your notes up. Okay, come by, cover your notes up, and then read the questions on the other side and see if you can't answer them. It's best if you have a study partner. You can trade, okay? You can trade notes. You say, I asked this question, you asked that question. Okay, we used to do study groups where, well, in the before times, you have to do a study group, and it's like, okay, we're going to do a test study group. You must bring 5 questions for this test, okay? There's a history test or something, or a psychology test. You have to bring 5 questions in order to come to our study group. And then we'd all trade questions, okay? And that's how we studied. So you want to practice, you want to bring, okay, everybody bring 2 problems. You can even assign them. You say, well, okay, Fred, you bring 2 exponential decay problems. Mary, you go ahead and take a couple of, bring us 4 reference angle problems because they're faster. Joanne, you bring us, you bring us 2 word problems for the triangles like this, and then we just all get together, and you get 6 problems to do now. Okay, and you have 2 other people to check your answers against. You don't help each other. Show each other the answer. I'm like, oh, I screwed up. What did I do wrong? Now help each other. Okay, but you don't have that. But you can come up with a couple of problems. There's plenty. Pick anything you want. Put the word worksheet in back of it in Google. I guarantee you'll come up with problems. You might even come up with the same ones that are going to be on the quiz. All right. I've talked enough. Good luck, and hopefully this helps. All right, I'm going to stop.